Hey, good to see you. Today we're going to talk about percent change or percent difference between two numbers. Maybe you got a raise at work and now you make more, or maybe you quit working out and now you can do fewer push-ups. Those are some of the examples that we can look at and see how do we find the percent change between two numbers. Enjoy the video.
Let's begin today's discussion, as we so often do, with a picture. Pictures can help us to understand what's really going on. We're going to have a story here, and the story is about a guy named Festus. And Festus lives in a 1,600 square foot house. Okay? Well, in this story, Festus decides to move to a new house. This house is bigger. It's 2,000 square feet. And what we want to know is, what is the percent change between these two houses? We started off in this house, or rather Festus did, and he moved to a bigger house, and we want to know the percent change on the square feet. So what I'm going to do today is I'm going to write down the percent change formula, and then what we're going to do is understand how it really works so that we can use this going forward, and we'll solve a couple more examples. Okay, so percent change
is defined as the final value minus the starting value, or what we call the initial, and then divided by the initial. And then to get it into a percent, we would just times by 100 at the end.
That will turn your decimal into a percentage, okay? This is the formula for finding a percent change, but what we really want to do is understand what we're doing, okay? And so I'm going to rewrite this formula in terms that might be a little bit easier to think through. Times 100, okay? We're going to use, instead of final and initial, we're going to do end minus start divide by start, okay? That way you can take a story, you can take a math problem, write it as a story, and then learn how to use this, okay? Let's look at this case where Festus is moving houses. He started in this house, and he ended in this house. End and start. So what we're going to do is we're going to fill out this formula with the information. So end minus start, that is a difference. That subtraction sign means the difference. It's the space between these two numbers, okay? End is 2,000. We're going to subtract where he started, which was the 1,600, and we're going to divide by the start, which is 1,600, okay? So this is the house that Festus ended in, and this is the house that he started in, okay? Which looks like this, which final minus initial over initial is what you will probably see if you look up a percent change formula, and this is what it actually means, okay? Let's put our times 100 on there, and let's go ahead and do the math. 2,000 minus 1,600 is 400. We're going to divide by 1,600 times 100, okay? And I can cancel these two zeros, which looks like 4 divided by 16 times 100, which is 25%. This means that the increase in the square foot for Festus's new house is 25%. So he could say, I moved into a house that is 25% more than what I started, okay? He started with something smaller, moved to something bigger, so that's an increase to go in this direction, and this is how much? 25% more. Something that is very interesting, and it's important to note, is that when you do the subtraction in the numerator, end minus start, the sign, and what I mean by sign is positive or negative, tells you something about the direction that you're moving. This 25% is positive. That means increase. Plus is going to be an increase, and minus is going to be a decrease. Since this 25% is positive, that means we've increased, and that makes sense in our story because Festus moved to a bigger house. The square footage increased, and that's why the 25% is positive. Let's run this backwards. We're going to do this story again, but now I'm going to flip this. And we're going to say that he ends, this time, he's going to end in the smaller house, and he's going to start in the bigger house. I'm going to go ahead and erase this board, and we will redo the problem and see what happens if we go the other direction. Our formula for percent change is going to be the same, but now the start and the end have switched.
So now he's ending at the 1,600 square foot house. And he started at the 2,000 square foot house. Okay? And then, because we're going to divide by start, we're going to divide by 2,000. We'll keep our times 100 here, and I'm going to go ahead and just work through this quick so that you can see the answer.
We see a couple of interesting things in this new problem. The first is that there's a negative sign, okay? 1,600 take away 2,000 gives us a negative, and that negative tells us something about the direction. It says that this percent change is a decrease. Isn't that what our story tells us? Festus now started in the 2,000 square foot house, and he moved into a smaller house. So the square foot decreased, which we see in our negative sign. So when you do this formula, whether you have a positive or a negative in the numerator tells you what direction. Am I getting bigger? Am I getting smaller? The other thing is that, didn't we use the same numbers, 1,600 and 2,000, and yet look at this. This is not 25% like before, it's 20%. If you move from one number to another, and then you go backwards the way you came with the same numbers, the percent change is not the same in both directions. That's an interesting feature of percent changes, is that the direction that you move actually changes the number, the percentage, if your start and finish number are the same. Just something to be aware of. All right, in this example, you've got a favorite pair of shoes, okay? These shoes have been $50 for a long time, and now it turns out through some kind of a clearance sale that they are $45, okay? So the shoes were 50 and now they're 45, and what we want to find out is what is the percent change between these two numbers. So we're going to use the same formula here, and on this one I'm going to explain the numerator just a little bit more. And minus start is a subtraction, which is a difference. It's the space between two numbers on the number line, okay? And so when we do a percent change, we want to know how far did we move, and then how big is that number measured against where we started, okay? So in this example, let's do the percent change here, all right? And what we're going to do is the end minus the start. Well, the end is where we landed, okay? The shoes were originally, they started at 50, they ended at 45. So we're going to do 45 minus 50, okay? We're going to divide by the start, which is 50. This is where the shoes started at. And this difference is going to be 45 minus 5 equals negative 5, okay? That's the change in dollars, $5, and the negative tells you that you're moving in the decrease, or you're going down. The price decreased or went down by $5. A percent change measures that difference or that distance on the number line against where did you start, okay? How big is this change compared to where you started? That's what a percent change is looking for, okay? And then let's put our times 100 on the end here.
Negative 5 over 50 is the same as negative 1 over 10 by dividing 5 out of the numerator and denominator times 100, and this is going to be a negative 10%.
Okay, that means 10% decrease, which makes sense because in our story, the price of the shoes went down. And we could do an example like this where we trade the prices and we say it started at 45, it went to 50, and what we would get is a different percent, and it would be an increase because we're going up. Let's take another example here. I'm going to say last month and today, all right? And these are going to represent the push-ups that someone wants to do. So last month, this person could do 20 push-ups, and today they can do 25. So they've been working out, they've been doing their push-ups every day, and this is what happened in the course of the last month. And they want to know what's the percent change. They want to tell their buddies, what is the percent increase on what I can do with push-ups? All right, so we're going to use that same model, and I'm going to work through this real quick so that you can see it, and then we'll talk about it when we're done here. Okay, we use the same model where we started at 20 and we ended at 25. So if we do end minus start, end is 25, we take away where we started, and then we divide by where we started. So 25 minus 20, that's the difference. That is the change in push-ups, 5. But it's measured against where you started, which was 20, okay? And so if you do the math here, 5 over 20 is 1 over 4 by dividing 5 out of the numerator and denominator. Multiply by 100 will change this into a percent. 1 over 4 is 0.25. Multiply by 100, 25%. And as you can see, the sign on this is positive, which means increase. Does that match our story? Yeah. Whoever's doing these push-ups is moving in the direction of increase. And if we were to flip these numbers, let's say you could do 25 push-ups and then you quit doing them for a while, and then later on you can only do 20, we would flip these numbers and we would see a negative and a different percentage, and that would represent a decrease. Let's try one last example that has a little bit of a twist to it, something different. And we'll use an example with money. And so in this example, the Federal Reserve is going to change their interest rate from 1.25 down to 1.00, okay? Maybe not terribly exciting for kids, but adults might be a little bit more interested in this. And the interesting thing about this is that the numbers that we're working with are already in percent. And does this still work, okay? Well, let's go ahead and write it out here. Remember that the percent change is, where did I end up? Well, I ended at 1%. Okay, and I'm going to subtract where I started, which was 1.25%, and divide by where I started. Oh, not start. How about a number? 1.25%, okay? And if we do this math, 1% minus 1.25% is going to give us a negative 0.25%. This is just doing the math, 1 minus 1.25, and we're keeping the units percent. In the denominator, we have 1.25%. Okay, something interesting for a different time, but if you have a fraction with the same units, they actually cancel each other, okay? So if units cancel, because they're the same in the numerator and denominator, then we can take a look at the numbers, and we have negative 0.25 as a decimal, divided by 1.25, just looking at those as numbers, and you will get a negative 0.2 if you put these digits into a calculator. Negative 0.25 divided by 1.25, you get a negative 0.2. So we need to multiply by 100 to convert it into percent, which is a kind of interesting because we started with percent. So you might be wondering, well, why would you need to do that step again? And it's because when you have units in the numerator and denominator that are the same, they cancel, and the final answer is a decimal, which we can multiply by 100 to re-express it as a percent. So in this answer, we would say, in this problem, we would say that the interest rates decreased by 20%, okay? Because a negative means decrease, we're going down, and that's what happened in the story. We started with a higher rate, and we ended up with a lower rate. That is a decrease, which the negative sign shows us right here.
So today you saw how we can calculate percent change with the same repeatable process every time. Thanks for watching, and we'll see you next time.